Hey guys, this is Shrish, and today I'm going to cover a very important computer network authentication protocol called Kerberos. The most frustrating part of an administrator's job is managing users' password. A user might have multiple passwords for the various services that he uses, and protection of this password tends to be very difficult. So Kerberos promises that it makes it easy for administrator to manage password by storing them centrally, enhancing security by ensuring no clear text passwords are transmitted, allow users to access different services with the same password, that is single sign-on. So one might come with a question. Why use Kerberos and why not just use a centralized location to store all the passwords? Well, that's a good solution and it decreases the amount of work on administrator. But the problem arises when the service needs to authenticate the user and it can't do so without these passwords. Another possible solution people might come up with is why not use a protocol that encrypts the password? Well, that's a good solution, but let's go through the scenario. Imagine you're in a cafe chilling out and the cafe happens to offer a free Wi-Fi access. So you open up your laptop connecting to the cafe's DHCP server and your laptop makes DHCP requests for several configuration parameters such as IP address of the DHCP server. Now let's take a scenario where there is another person in the cafe who has a fake DHCP server in his laptop. Let's call him an imposter. So the fake DHCP server distributes information pointing the client towards his server. So the fake entries of many mail servers that the client may possibly use is pointed towards the imposter server. This, you might know this as spoofing. So the problem which arises over here is even though if the user tries to connect to his mail server using the DHCP server of the imposter, he might not connect successfully, but the information that he has provided can be harvested by the imposter for various other uses. That's why we use Kerberos. So Kerberos was developed in MIT during 1980s under the project name Athenas. The word Kerberos is actually the three-headed dog guarding the gates of Hades in Greek mythology. This is Kerberos from Greek mythology. So the word Kerberos itself explains a lot about how it works. Just like a three-headed dog, in the network authentication, Kerberos creates a realm with three players that collectively guard her network, namely Kerberos Client, Kerberos Service, Kerberos Key Distribution Center or KDC. So let's see how it works. The Kerberos client and Kerberos server in Kerberos realm are called principals, and each principal have their own private key as depicted here. They don't share these private key with each other, and only they share with the KDC. The KDC itself has its own private key which it does not share with anyone in order to maintain authenticity. So let's see how Kerberos works. There's the client, and the client connects to the network by entering username and password. A package is created from the client principal which contains the username. Note that the password has not been transmitted to the KDC. So the username is transmitted to the KDC, where KDC checks its database to find a match for the username. If a match is found, the private key of the user. The main reason for this transaction is for the packet to request for a TGT, that is ticket granting ticket, so that the client can access various services that he requires. So a TGT is actually time sensitive, so it is time stamped. TGT contains the following: username, KDC name, client IP, and a session key. A session key is actually a time sensitive key, and it changes periodically in order to decrease any chance of external decryption. So, after the TGT is created, the TGT is encrypted using the KDC's private key, and a packet is created which contains the TGT and the session key, and this packet is encrypted using the user's private key. And when the packet reaches the user, the password that he entered to connect the network is used to decrypt the packet, and the TGT and the session key are retrieved. The TGT is stored in a specialized memory location in the computer called a Kerberos tree. This special memory location cannot be swapped out of the disk. That is, it always lives in the disk. The advantage of this is, even if this network crashes, the information will always be stored in the memory and can be retrieved later. Now, in order for the client to access various services, the client creates an authenticator. The authenticator contains username, client IP, and it is timestamped. And this authenticator gets encrypted using the current session key. Now a packet is created in order to include the TGT, the current session key, and the encrypted authenticator. And this packet is sent to KDC again. Now the KDC knows that the TGT is authentic because the user doesn't have the key to decrypt the TGT. So the KDC uses its private key to open the TGT and access all the information, and it uses the current session key to open the authenticator, and it cross-references both the information from authenticator and TGT and finds a match. If there is a match, then the KDC creates a service ticket. The service ticket is actually a unique ticket which is unique for the particular service and for only that particular client for a particular period of time. The service ticket contains username, service name, client IP, and session key copy. If you note right here, it's a different session key from the one we used before. This is because the session key has changed. Now, the service ticket is encrypted using the service principal's private key, and a packet is created which includes the service ticket and the copy of the new session key. Now the packet is encrypted using the old session key and is sent to the client, and the client uses the old session key which is stored in a Kerberos tray in order to decrypt it and retrieve all the information. Now the user creates another authenticator to send to the service, and now it encrypts the authenticator using the new session key, and a packet is created in which a service ticket and the new authenticator is included, and this is sent to the mail server. The mail server retrieves this information and uses its private key to decrypt the service ticket. It very well knows that only KDC will have sent this service ticket, as it is the only one which has a copy of its private key. After using its private key to decrypt, the service retrieves all these information, which includes username, service name, client IP, and the new session key, and it takes this new session key and opens the authenticator. Now it cross matches to find any match between the authenticator and the information in the service ticket. If a match is found, then the service is provided to the client. So by doing so, Kerberos has managed the following. It has managed to create more secure authentication, simplified management of password, and convenience of single sign-on. The most important thing to be noted here is, in no point of process, the password of the user is being sent to anyone and not even to the service. So the password is very secure. This brings to the end of our topic today. Thanks for watching.